Please welcome Jodi Forlizzi.
Thanks. Hi, everybody. Thank you for the opportunity to spend time with you today. I am a professor in the Human-Computer Interaction Institute at Carnegie Mellon University, and I am not a computer scientist. My training is in design. So today I'm going to talk about the human aspects of interacting with ML and AI and the human experience, which is really important. So earlier this year, there was an article in The Economist that decreed that data is a new economy. Data is the new oil. And it's true, as we know, data has enabled a lot of new things, new products, new services, new businesses, and even new economies. So this sea change is being felt in my discipline, design. We have increasingly been tasked with designing new products, services, and systems that use data and ML and AI. So whether we're designing things like mail filters that move messages on your behalf, or new services like Medium that can give you content based on what you like, what you tag, and what predictions are made for you, or conversational UIs like Amazon's Alexa that use AI to make predictions about what customers would want to do, or autonomous vehicles that rely on algorithms for path planning and localization. In all of these cases, we need to understand what people are going to do with these kinds of systems. So we need to look at how the best ways are to design them. So while a lot of companies are focused on this, my research question is, how do designers work with AI in a data-driven economy? And so Joy Ito, the director of the MIT Media Lab, has also noticed that design is changing. He said, design has evolved from the design of objects, both physical and immaterial, to the design of systems, to the design of complex adaptive systems. And this evolution is shifting the role of designers. But really what I get asked every day are questions like, will robots take my job? And will AI cause computers to act unethically? So I think the answer for the common public is that AI is not taking anybody's job yet, and neither are robots, but we need to begin thinking about things. So I want to set the context a little bit. So the first thing I want to talk about is a shift from manufacture to service delivery in the past few decades in the world. This graphic from the New York Times shows that around 1960, the largest, most profitable companies in the US were goods-producing companies, companies like GM, Esso, and ITT. But then around about 2010, there was a shift, and the largest, most profitable companies in the US became service delivery companies, companies like Walmart, IBM, Kelly, and Target. And with this change from consumer goods being on the decline, we saw the rise of services devoted to particular purposes, what Ezio Manzini called systems of interlinking services. So this suggests a change in how we design. The second part of the context, of course, is that technology is generating massive amounts of data. Smartphones, IoTs, customer trails, what people are doing is creating a lot of data. It's great data that we can work with, and designers now need to figure out how to integrate these technological changes into the experiences that we design. And then, of course, customer expectations are rising. Customers are doing business on their own terms. They're doing things like writing reviews, price seeking, and we need to respond to all of this. We need to respond to the empowerment of the consumer and the way that we deliver products and services in response. So we're now in an era where products have evolved into intelligent, connected devices. And people come to us all the time and ask how they can shift their companies from being commodity-driven to being data and service-driven. So these products are sometimes called smart products or smart connected products. They're comprised of a physical product, sensors that collect data about its use, and computational technology to make sense of the data. This is one example, the Hydrate smart water bottle. Last year, Mattel, the maker of Barbie, purchased an AI startup to create an intelligent Barbie that could remember things and have conversations with the girls and boys that she played with. And you may remember, too, that Mattel was also working on another product to monitor and interact with children, and that was pulled off the market. So when we link smart products together with computational technology, they become a platform. A platform is a system that can be programmed and therefore customized by outside designers, by developers, and even by customers to build in needs and specialties that maybe no one anticipated. And that can be good or bad. These platforms can be hardware or software. In the core, we have the product layer that contains things like the hardware, mechanical, sensors, and connectivity, software like the embedded OS and the user interface elements. These are wrapped in a connectivity layer that contains network communications between the product and the cloud. And then at the top, we have the cloud computing layer, which contains product data, both real-time and historical, apps and analytics, and even information about how and where this product was manufactured. These also exist in a context of identity, privacy, and security, and they're weighed on by other data forces, for example, maybe weather or traffic. Platforms are not new. They've actually existed in concept for a lot of years. So you can think about a mall. This is a picture of a mall from the 1970s. They were platforms that brought together shopping and dining services. So we can begin to think of these platforms as offering bundles of things that people might want and need, optimized by patterns found in data streams. So when platforms encompass smart products, people, data, services, and elements of context, they're known as product service ecologies. And these are very systemic and complex things, and they're more complex than things designers have ever designed in the past. And these product service ecologies are transforming industries in new ways. So one example is John Deere's smart tractors. These are devices which are transforming the farming industry. You may have read about them. Like most product service ecologies, this system has physical components, sensing components, data components, and even human components. They have the tractor itself, which is a product which does the physical task. Then they have sensors on board that provide dashboards of analytics. There is other information that can be linked in by other farm equipment systems that can help to optimize the operation of the tractors. And then this can be linked to other data streams such as weather maps, farm performance. And totally, in sum, we are then creating devices that can optimize and predict what crops are going to do and change farming altogether. So that's a great story of how an industry, farming, is being changed, but there are loads of opportunities to create better experiences. So I was on a United flight from San Francisco to Pittsburgh a few months ago. It was early in the morning, about 7:30, and the stewardess came to the man across the aisle from me and she said, "Excuse me, sir, you've just crossed an important milestone. Would you like a cocktail?" And he looked at her and he said, "What?" And she said, "I know, sir, it's really early in the morning. Would you like a fresh-baked cookie?" And he looked at her, and by this time everybody was stirring, and he said, "Do you have the right guy?" And she said, "Yes, Mr. Jones, you've just flown your millionth mile with us. Would you like a cocktail or a cookie?" And he said, "No, I'd like to be upgraded to platinum." So this was an excellent example of someone trying to use data collected about a customer and it failing miserably. And you can think about this happening in industry after industry. For example, healthcare, where we have clinical data, we have data about people, and we cannot link these together in any meaningful way. So there's many domains of opportunity, for example, retail, where we have siloed data sources about customer behavior. Credit card data, loyalty card data, in-store data, and online data. Manufacture, where we have siloed data in legacy systems. And healthcare, where we have many, many interoperabilities between the kinds of data that we're collecting and using. So now you can probably see why design is playing a role here, and I want to talk a little bit about some of the reasons design is important when working with ML and AI. And the first idea is that designers can act as human tenders for data-driven products that use machine learning and AI. So in some of my previous research, we study how data-driven services might benefit both customers and service providers. And some of the results of our research showed that opportunities to use this data to create better service include things like recognizing customer loyalty, not as United Airlines did, but maybe in a more constructive way. Preventing customers from making errors, so you don't end up going to Home Depot 5 times in a row when you're trying to fix a broken toilet. Pointing out new and relevant services. You just bought this salmon, here's some wine that might go with it. Validating previous service breakdowns. I know your flight to Boston was late last time. Let's try to do better and accommodate you a little bit better. And then finally, capturing and acting on service orientation. So we got really interested in this idea of recovering from error based on this video of one of our robots delivering a drink to a bin. So what you're going to see when you watch this video is that the robot makes an error. And I want you to look at and listen to how committed people are to this thing doing it the right way. So in addition to errors, we became really interested in this idea of service orientation. So research has shown that there's typically 3 frames that people use when they're interacting with technology services: relational, utilitarian, and oppositional. In the relational frame, people want to have a social and emotional experience with technology. This has been talked about in research at HCI for a long time. We look at the computer as a social actor. In a utilitarian frame, however, people don't want to have a social or emotional experience with the technology at all. Instead, they want to maximize their value for the time spent interacting with technology. And then finally, in the oppositional frame, people don't trust the technology at all, and they may not want to interact with it at all. So we designed and developed a snack delivery robot to study some of these issues over the long term. So this was a robot where, using a website, people could order snacks to be delivered to their office. This was a long-term field study done in 2 wings in my university. And we allowed people to order fruit, cookies, or candy based on the website. And so we wanted to investigate these ideas of breakdown and recovery, and so we wondered, could we use a strategy that works even before a robot makes a mistake? So warning in advance that the task is hard and the robot might make an error. And when the robot has to recover from a breakdown, would these frames, relational, utilitarian, and oppositional, be helpful? And should they differ depending on the customer? So this is a video of SnackBot doing its job.
I have an order for Kathy. Please take your cookie. Thanks, Kathy. Enjoy your snack. I hope you have a wonderful day. Goodbye.
So you can imagine this was a pretty fun study. It ran for several months. We collected a lot of data about people's perceptions of the robot, how much they trusted it, how much they liked it. We collected data about whether they changed their choice of a healthy versus unhealthy snack when a robot knew what they were taking. We collected data about how they conversed with the robot, the number of conversational turns, whether they used a pronoun. And we saw a lot of fun and interesting things. For example, the robot broke down in front of someone's office, and the next day she brought the robot a snack. She brought it a battery. So we saw a lot of really interesting measures of sociality and reciprocity. So in this study, we wanted to look at service orientation and service personalization, and we wanted to use those frames that I talked about a few minutes ago. So we used this scenario-driven study where we had a person, Chris, who needed help, and Chris was thirsty and asked the robot to bring a can of Coke, and the robot says, okay, And then the robot makes a perception error. It goes back and brings a sprite. And after a few minutes, the robot comes back, and Chris says, okay, good, but I wanted a Coke. And then we had 4 conditions based on those frames where the robot varied its behavior. In one condition, it didn't do anything. In the second condition, it apologized. This is the relational frame. This is the easiest thing to do. It conveys politeness and empathy, and we wondered if it would work with a robot. In another condition, the robot offered to get a drink for free. This has been shown to compensate people's time when they feel like they're losing value, and it would probably work with the utilitarian frame. And then in the last condition, the robot offered to go back and get the right drink. And this is for the people who don't trust technology, because it's been shown in the literature that alternative options make people feel like they have a sense of control. And then in half the conditions, we used expectation setting, where the robot warned in advance that the task might be hard. So this was a scenario-based study. We actually didn't build all these behaviors technologically. We demonstrated them. And this is a great design method when you want to cover a design space with many, many instantiations or possibilities, and you don't know which ones are going to be right. So we ran this 2x4 experiment where we had forewarning or no forewarning as a condition. We used 2 robots to make sure the appearance of the robot would have an effect or would not. We also used the arm, and it turns out the appearance had no effect at all. And then we had our 4 recovery strategies: no recovery, apology, compensation, or options. So we showed people a video. They did the task. Before they looked at the study, we rated their cultural frame, orientation to technology, and afterwards we had them evaluate the robot and the service and the likelihood that the service would be used again. So first I'll talk about the effect of forewarning. Forewarning the users that the task is difficult significantly improved participants' judgment on whether the robot provided good or bad service, but it didn't encourage them to use the service again. However, the robot that warned in advance was seen as being very capable and very trustworthy. And then the effect of our 3 strategies: apologizing, going back to get the right thing, or offering a free drink. It turns out that apology was by and far the most successful. When the robot apologized, people thought it was more capable, they trusted it more, and they felt that they would use it again. And so this means that if we can predict even simple things about users' behaviors, we can better deliver these kinds of strategies to them. And it turns out that we can reliably predict these frames that people are going to use when orienting to technology. So a common vision is that AI systems will evolve perfectly and effortlessly, and this is not the case. So another way that design can work here is to provide intervention when the AI is incapable of delivering a viable solution. So we designed this educational game called Battleship Numberline, and this is a game where kids learn about fractions. This is a common learning problem with middle-aged students. And we wanted to look at how we could design more motivating and challenging games. And this game runs online. So here's a little video of how it is played. You are shooting a target down at a fraction to show that you know what the correct answer is. So this is a very large design space, and it's even a combinatorial design space. Here, we used the crowd as game players, and we used AI-optimized game variations, and we could begin to run super experiments to understand what helps students learn best. And so we found about 13,000 variations with changes to the target type, the target size, whether people clicked or typed, the size of tick marks, scaffolds for estimating and sequencing, and even things we learned about players in a pre-test and a post-test. We had about 70,000 gameplays. One of the things that we learned is for some players, the game is more motivating and more engaging when it's easier to play. And so rationally, it becomes this idea that the battleship target becomes larger. So we began to use AI to optimize elements of the game to make gameplay easier for students who had problems. But as you can see, the algorithm spun out of control. And here, the optimization resulted in a game that wasn't feasible to play. So the optimization that thought it was good enough turned out to be actually very faulty and didn't deliver a good game experience. So the final thing I want to touch on is how AI systems will intentionally and unintentionally impact people's lives. And so investigating these questions asks how people perceive AIs, how they make sense of them, how they become dependent on them, and how they derive value from them. And so here again, we make prototypes that help people understand how AI is working, especially when there are no social norms that yet exist around the technology. So we did a case in healthcare looking at VADs. VADs are mechanical heart devices, which are often implanted in patients as a last resort. And often doctors use decision support tools to help figure out when it is time to implant the VAD. However, few of these systems integrate well in clinicians' workflows, and many patients die after receiving a VAD. And finally, cardiologists who implant VADs feel like they don't need help making the decisions. So this suggested that we needed to better understand these decision support tools, and the design team here was tasked with bringing AI to the clinicians to make a better decision support tool. And this was a problem because the clinicians didn't want it. So they did design-focused research, and they found these typical pathways that decisions are made to implant a VAD. The first is an emergent pattern. The patient is sick, they go to sleep in surgery, they wake up with a VAD, there's no time for a decision support tool. The second is the most typical. There's a cyclical decline. People get well, they get worse, they get well, they get worse, and a VAD is implanted after the drugs stop working. And then a third pattern is a late referral. Patients are too sick for surgery, but they plead anyways, and they get a VAD. So collectively, these patterns pointed to the need for a decision support tool for cardiologists. So the solution came to the research team as a result of reframing and pivoting how AI might work with these clinicians who said, we have all the knowledge to make the decisions now. So what they designed was AI in the form of a PowerPoint slide generator. The clinicians already used PowerPoint slides to do their rounding, and they began to see AI in the slides. In fact, they saw a very small score about how the AI was working. And this confidence score began to allow them to build trust as the decision support tool enhanced by AI began to agree with them. So this was a very different ending than people originally interpreted, but through design, understanding what people needed and reframing, we were able to use AI in a way that did not impact the clinicians' importance in the work that they did. So in conclusion, today I talked about how the world is dealing with an abundance of data, how design and service design are changing in response, and how design's human interaction with technology is needed. We can provide human intervention in AI-driven design spaces. We can help people understand the capabilities of AI, especially when it seems like it's going to change or remove their jobs. And we can create AI systems that people trust and collaborate with fluidly. Thank you for listening.